Hello and welcome to this webinar on the exciting new features in NRF Connect SDK version 1.8. I am one of your hosts today. My name is Bjorn Kvale. I'm a product marketing engineer at Nordic Semiconductor. And with me I have Christoph, who's a technical product manager for short-range wireless. And I also have Martin Lesund, who's a technical marketing manager on cellular IoT. Just some quick practicalities before we get started. So the duration of this webinar will be approximately 45 minutes and 45-minute presentation, and then we'll have a 15-minute Q&A at the end. Questions are encouraged, but please type the questions in the top of the right sidebar. All of the questions are anonymous, but please try to keep them relevant, and we will answer towards the end. The chat on the bottom right is not anonymous and should not be used for questions. And feel free to go to DevZone, Nordic DevZone, if you do have any more questions. So that's at devzone.nordicsemi.com. And last but not least, a recording of the webinar will be available together with a presentation at webinars.nordicsemi.com/on-demand. So just a quick agenda before I get started. So I'll give a short intro to the NRF Connect SDK and some of the basic terminology, and then I'll hand over to Christoph for the short-range updates, and then last but not least, Joachim will look at the cellular IoT updates for NRF Connect SDK version 1.8, and then we'll have a Q&A at the end. So communities, we do have quite a few communities you can browse. We of course have webinars, so that's great for technology intros, high-level trainings. That's at nordicsemi.com/webinars. We also have the Nordic Developer Zone, Nordic Dev Zone at devzone.nordicsemi.com. We have roughly 40 full-time engineers working there, helping you with tech support. As you can see, it is a vibrant community. We have had 3 million page visits in the last 6 months. And last but not least, we also have Nordic GitHub. So there we have a bunch of different repositories, mostly written in C, but we also have some C++, Python, and JavaScript. And that you can find at github.com/Nordic Semiconductor. So now I'll go over to the introduction and basic terminology. So the NRF Connect SDK is one codebase and toolchain for the NRF 91, NRF 53, NRF 52, and NRF 21 series. The NRF 21 series is our 2.4 gigahertz range extender, but it is optional for the NRF 52 series. So that's as of version 1.3.0 of the NRF Connect SDK. It does include a lot of different protocols, so just naming a few: LTM, narrowband IoT, Bluetooth Low Energy, Bluetooth Mesh, etc. So we do have quite a few protocols supported there, and the Bluetooth Low Energy stack is version 5.2 qualified, both the host and the controller, since version 1.41 of the NRF Connect SDK. On the NRF 52 side, on the NRF 52 series SDK support, we do have the NRF 5 SDK. So that is very good if you do not require a real-time operating system. Also, if you're used to this SDK and you don't require newer features after Bluetooth 5, Bluetooth Mesh 1.0.1, Thread 1.1, or Zigbee 3.0, release 22. But if you do need newer features, so then we definitely recommend using the NRF Connect SDK. So that the NRF Connect SDK will support newer features after Bluetooth 5, Bluetooth Mesh 1.0.1, Thread 1.1, or Zigbee 3.0. But yeah, so I guess if you're just getting started with development now, it's definitely a good idea to start with the NRF Connect SDK. And if you have any more questions about that for the NRF 52 series, you can see we have a statement on DevZone for more information. Okay, so moving on to the code base. So there we do have application code, all of the connectivity protocol, wireless stacks, and also peripheral drivers. That's all located in the code base. It is organized into 4 main repositories or 4 main folders, and that is Nordic and open source code. So you can see the Nordic code is in blue on the figure to the right, and the open source code is in purple. So the 4 main repositories, you can see below there is we have the NRF repository. So that's where we have a lot of applications and samples for kickstarting development. So you don't need to start from scratch. That's where we have a lot of the connectivity protocols too. On the NRF xlib repository, that's where we have peripheral drivers and also some stacks. So that's mainly RTOS independent libraries. On Zephyr, we do have, that's where we include that's where the RTOS, the real-time operating system, board configuration, kconfig, device tree. I'll talk a bit about that in one of the later slides. That's where that is located. And MCU boot, that's the secure bootloader. So for firmware upgrades. So just some quick, basic terminology on NRF Connect SDK. We do use Git, so that's an open source distributed version control system if you need to manage source code changes. Distributed basically means that all of the code and history is located on each of the developers' PCs. We have the West tool, so that's a Zephyr tool, and it's a command line tool for multi-repository management. So since we are not only using one repository, right, we're using 4 or more repositories in NRF Connect SDK, West is a great tool for managing the multiple repositories. And with the West tool, you can also build and flash examples too. Repository, like I said, that's a version controlled project folder. So for example, NRF or Zephyr, or if we go back here, NRF xlib, MCU boot. And every code commit does create a different repository version with a unique secure hash algorithm identifier. So tag, that basically points to a specific commit SHA identifier. So that's immutable. That means it doesn't change. So for example, version 1.8, that's an example of a tagged release of NRF Connect SDK. It is human readable. So yeah, version 1.8 is a lot easier to read than the jumble of text that often is an SHA identifier. And for the tagged releases, we do have Nordic dev zone support available. The master branch, that points to the most recent commit SHA. So that's basically the most recent version of NRF Connect SDK. That is mutable, so it's always changing with each latest commit to the master branch. But it's a great way to start testing newest features earlier if you can't wait for the tagged release. But for the master branch, we do not have dev zone support available. So moving on shortly to the source code and configurations. Like I said, we have West, so the multi-repository management tool. That's how you can clone and update the code base. So you can see on the figure below, you have the NRF Connect SDK here. So containing all of the different repositories, and then you can add your code, and then that then becomes the code base. So that's how you can clone the code base using the West tool. And then, for the different applications, you can then use kconfig. So that is basically it stands for Zephyr kernel config, and that's how you can set up the different features for the different applications. So if you need to use, let's say, GPS on one of the applications, that's how you can set up that feature using kconfig. And then last but not least, we have the device tree. That's how you can set up the target board description. So that's how you can configure the target. So each of these, let's say if you're using a Thingy 91 or an NRF 52840 development kit or a reference mouse design, the device tree files will look slightly different because you have different GPIO pin mapping, etc. You're basically describing hardware slightly differently for the different kits. Moving on to release cycles. So the release cycles are roughly on a quarterly basis. It is publicly hosted on GitHub, so you can click on the link. I'll include the PDF. You can click on the link to find where it is hosted. The fixes are released as needed. So long-term supported releases can have fixes applied and delivered after new releases. That's what you can see on this diagram here. So you have the major tag, and then if you have a new release afterwards, so the minor tag, what you can do is, what will happen is sometimes is that you'll have a fixed release, so X0Z that might come out after the minor tag has already been out, for example. I think the main thing there is, we do take bug fixes very seriously, and we want, high quality code for you developers. The latest development version is also available, so that is the master branch. If you need to test out newer features earlier, if you can't wait for a tagged release, and the version control management is done with Git. That's how you can manage new versions, also fix adoption, etc. And Git does support merging too. Okay, so we used to, in the NRF Connect SDK documentation, we used to say supported for development and supported for production. Now we have moved over to experimental versus supported instead. So just a quick run through on what that means. So experimental features and components that can be used for development, but it's not recommended for volume production. So the technical support is available, at least for the tagged versions. So for example, version 1.8. Reported bugs may not be resolved until the feature is supported. The implementations may be partial, so they might change while we move from experimental to supported. Also, the APIs might change going to supported, and the verification is incomplete. So I think the main point here is that if you're using an experimental feature, and that will be shown in the kconfig. So when you're building a program, you'll be able to see if the feature is experimental or not. And so that is very suitable if you have a prototype, if you want to prototype, or if you need to evaluate. But it's not recommended for end productions. If you need a feature for end production, then you need to wait until that feature is supported. So that will be maintained. Supported features are maintained, and it's also suitable for product development. Their technical support is also available, at least for the tagged versions. Critical bugs that are reported will be resolved in both master and latest tagged versions of NRF Connect SDK. The implementation is complete there, and that is verified for product development. So that is, it's suitable, supported features are suitable for integration in end products. But yeah, like I said, this is shown, it's shown quite clearly in the documentation and also in kconfig. So yeah, just quickly on the NRF Connect SDK documentation. So I have a link to the documentation if you want to look at that. Like I said, I'll include the PDF, so you can click on the link there. So on the documentation page, you'll see on the top left-hand corner of the screen, you can see this. And there you can see the tagged version. For example, so if here we're on version 1.8.0, but if you click on this little arrow, it will then expand to show this. And there you can then switch between the different tagged versions of NRF Connect SDK or the latest version. So that's the master branch. Yeah, so that's a very easy way to switch between the different documentation versions. And then on the bottom left-hand corner of your screen, you'll see this. If you click on that arrow there, then you'll be able to move between the different repositories. So if you want to switch to the NRFX lib documentation, you can easily do that. Same for Zephyr project, MCU boot, etc. So that's a very simple way for moving between the different repository documentation. So just quickly on the ID support. So you might have, we have released the NRF Connect for VS Code. That's a VS Code extension. It is built from the ground up for supporting NRF Connect SDK. It's highly extendable, highly configurable, very flexible. You do have both a command line interface and a GUI interface, and the support is cross-platform. So we do have it supported for Windows, Mac OS, and Linux. And it also includes a new board wizard for getting started with different boards. And we do have a rich set of tutorial videos at that link where you can see, how to install NRF Connect SDK and also VS Code, and it goes through step by step how you get started with programming. But we do also have Sega Embedded Studio Nordic Edition support, so that is cross-platform support for Windows, Mac OS, and Linux. And you can also use any other IDE with the NRF Connect SDK, but then you won't have NRF Connect SDK or toolchain integration. So I think our main recommendation is using NRF Connect for VS Code if you want to get started. So now I'll talk quickly about some of the generic updates in NRF Connect SDK version 1.8. So we do have this experimental feature. So if you set the config warn experimental equal to yes in kconfig, it's on by default. Then you can set features in kconfig or project config file. For example, if you set periodic advertising, what will then happen is that if you do build a sample that does contain experimental features, such as periodic advertising, then that will lead to you getting a warning message. And so this can be seen here. So here, the Bluetooth periodic advertising, which is still an experimental feature, is set in the project config file. And then we can see at the bottom that you do get a warning message there. And now I'll hand over to Christoph, who will talk more about some of the generic updates and short-range updates in NRF Connect SDK version 1.8.0.
Hello, my name is Krzysztof Loska. I work as a technical product manager for short-range wireless. And today I would like to present you exciting new features regarding short-range wireless protocols in NRF Connect SDK 1.8. Let's start with updates for the SoftDevice Controller. The SoftDevice Controller, which is Nordic's Bluetooth LE controller, now has experimental support for periodic advertising, a key feature for connectionless Bluetooth direction finding and Bluetooth LE audio broadcast. For the NRF 52 Series SoCs, the SoftDevice Controller now supports a three-wire packet traffic arbitration interface, or PTA interface in short. This is a common coexistence interface used by Wi-Fi radios. Also, for the NRF 52 series, the SoftDevice Controller now has experimental support for one-wire PTA interface, a coexistence interface specifically for the NRF 9160 system in package. Additionally, the SoftDevice Controller adds support for the simple GPIO front-end module implementation on the NRF 53 series. This enables you to use NRF 5340 system on chip with NRF 21540 front-end module for Bluetooth LE communication. You should already be familiar with NRF 5340, but let me remind you what it is. The newest addition to our short-range portfolio is NRF 5340, which is a dual SoC SoC. The application processor is optimized for performance and allows you to perform time-critical application tasks without being affected by radio stack execution. The network processor is optimized for low power and efficiency and is responsible for radio operations. Additionally, NRF 5340 provides the advanced feature set and an operating temperature up to 105 centigrade. Combination of both features make it the ideal choice for LE audio, professional lighting, advanced wearables, and other complex IoT applications. In the default configuration for NRF 5340 system on chip, SoftDevice Controller runs in the NRF 5340 network core, and Zephyr Bluetooth host runs in the NRF 5340 application core. They communicate with each other using HCI RP message transport. NRF Connect SDK version 1.8 adds experimental support for running the entire Bluetooth stack in the NRF 5340 network call, with full Bluetooth LE host API exposed to the application core. This is possible by using the NRF RPC library. NRF RPC library allows for calling a function on a remote processor from a local processor in both synchronous and asynchronous way. The library is RTOS agnostic and implements serialization of function calls. It is designed to be used with an underlying transport layer, like OpenAMP, which enables inter-processor communication on Nordic semiconductor SoCs like NRF 5340. Let's spend a minute analyzing the presented diagram. On the right-hand side, we see NRF 5340 application core, which runs a user application. When the user application calls a Zephyr Bluetooth host API, the call is serialized and sent to the remote processor using remote procedure call library over OpenAMP transport. OpenAMP transport uses the shared memory and hardware RPC mechanisms. The same transport is used on the network core side. Finally, the call is deserialized, and the appropriate Zephyr Bluetooth host function is called. It works the same when communicating from the network core to the application core, for example, sending a response or notification. Depending on the transport layer, the remote processor is not limited to a single device. It can also be a separate device of any type, for example, a PC, or another processor on the same system. You can use the solution provided in NRF Connect SDK for NRF 5340 as a basis for using any NRF 52 series SoC as a Bluetooth LE network processor with full Bluetooth host API exposed to an external MCU. To achieve that, you should replace the open AMP transport with a physical transport, like UART or SPI. Such solution would be an equivalent to SoftDevice serialization you may know from NRF 5 SDK. Today, NRF RPC supports only open AMP transport. If another transport is needed, it is up to a user to implement it. The Bluetooth host for NRF RPC Bluetooth Low Energy sample is designed specifically to enable the Bluetooth LE functionality on a remote MCU. For example, the NRF 5340 network core using the remote procedure call library. You can program this sample to the network core to run standard Bluetooth low energy samples on NRF 5340. You can use either the SoftDevice Controller or the Zephyr Bluetooth LE controller for this sample. To use the Bluetooth LE stack through NRF RPC, an additional configuration is needed. When building samples for the application core, enable the config_bt_rpc_stack to run the Bluetooth LE stack on the network core. This option builds Bluetooth host for the NRF RPC Bluetooth Low Energy automatically as a child image. One of samples having a ready-to-use overlay with this configuration is Bluetooth Peripheral UART sample. You can find more information in NRF Connect SDK documentation. NRF Connect SDK 1.8 adds a new Bluetooth sample. Bluetooth Central and Peripheral HRS sample demonstrates how to use Bluetooth with central and peripheral roles concurrently. It also demonstrates how to use the GATT heart rate service client library. When a device is connected as central, the sample starts the service discovery procedure to search for the heart rate service. If this succeeds, the sample reads the body sensor location characteristic and subscribes to the heart rate measurement characteristic to receive notifications. When connected also as peripheral to the device acting as a heart rate service client, denoted as heart rate monitor keyer, the sample starts working as a relay. It collects data from a remote device with heart rate service that is sending notifications and sends this data to another remote device providing a heart rate service client. You can test the Bluetooth Central and Peripheral HRS sample together with the Bluetooth Central heart rate monitor sample, and Bluetooth Peripheral HR sample running on separate boards. NRF Connect SDK 1.8 adds Bluetooth mesh and peripheral coexistence sample, demonstrating how to combine Bluetooth mesh and Bluetooth low energy features in a single application. The purpose of this sample is to showcase an application where a peripheral can operate independently of Bluetooth mesh. It combines the features of the Bluetooth peripheral LBS sample and the Bluetooth mesh light sample into a single application. Bluetooth mesh samples also add support for NRF 21540 DK. Matter is relatively new technology, so let me introduce what it is. The goal of Matter, which before rebranding was called Project Connected Home over IP or Project CHIP, is to unify smart home by specifying a new application layer running on top of IP, Internet Protocol. Version 1.0 of the specification targets Wi-Fi and Thread as main connectivity protocols. Bluetooth LE is used for commissioning of new devices. The project involves engineers from Amazon, Apple, Google, Samsung, and over 200 other companies collaborating together to simplify development for manufacturers and increase compatibility for consumers. Nordic is an active participant in Matter from day one and provides full support for the project for suitable SoCs within NRF 52 and NRF 53 series. The project is still under development with the goal of being ready for production in Q2 2022. NRF Connect SDK 1.8 provides an optimized solution with regards to energy consumption of battery-powered Matter over Thread devices. It also features better documentation and more user guides to help you quick start with Matter development. NRF Connect SDK 1.8 provides an updated integration of Apple's Homekit accessory development kit, which is now present in version 6.1. NRF 5340 system on chip is now supported for production for both types of HomeKit accessories, HomeKit over Thread and HomeKit over Bluetooth LE accessories. You can also combine NRF 5340 with NRF 21540 to achieve better output power and sensitivity. Apple HomeKit solution is distributed as a private GitHub repository. MFI licensees can get access to this repository by contacting us via Nordic DevZone private ticket. NRF Connect SDK 1.8 adds also a new Zigbee sample and library called Zigbee Shell. The Zigbee Shell library implements a set of Zigbee Shell commands that allow you to control the device behavior and perform operations in the Zigbee network, such as steering the network, discovering devices, and reading the network properties. Enabling a device to work with these commands simplifies testing and debugging of an existing network and reduces the amount of reprogramming operations. The Zigbee shell commands are implemented using Zephyr's shell interface. A coprocessor design can be used when a device requires additional functionalities on compute power not present in Nordic SoCs, but a more powerful processor does not have a suitable radio interface. Split stack architectures are most commonly used to design Zigbee gateways, but sometimes also for complex end devices. A popular coprocessor design is the network coprocessor architecture, or in short, NCP. NRF Connect SDK 1.8 features new version of the Zigbee network coprocessor host software. Zigbee Quick Start Guide has also been added to facilitate easy start with Zigbee development. And last but not least, NRF Connect SDK 1.8 adds support for Gazell. Gazell is a proprietary 2.4 GHz wireless protocol for setting up a robust wireless link between a single host and up to 8 devices in a star network topology. It is designed to minimize power consumption in power-sensitive wireless desktop products, and is also suitable for a range of other wireless applications. A typical example is a wireless mouse communicating with a USB dongle that is inserted into a computer. NRF Connect SDK 1.8 adds support for Gazell for all NRF 52 series SoCs with related libraries and samples. That's all when it comes to short-range wireless updates. Nordic short-range wireless team wishes you a prosperous and healthy 2022. Happy New Year!
Hi, and now it's time to look at the cellular IoT updates that we have in NRF Connect Software Development Kit version 1.8. So first off, I just want to highlight the complete low-power cellular IoT solution that we, Nordic Semiconductor, provides. On the left-hand side, we can see the NRF 9160 system in package, which has a dedicated application processor and a memory. It's a M33 ARM Cortex, and we have 1 megabyte of flash and 256 kilobytes of RAM. It also includes a multimode LTM and LTE Modem with the integrated radio frequency front end and GNSS support. And of course, this hardware was built from the ground up to be ultra low power. On the middle here, we see the NRF Connect family. We have the NRF Connect Software Development Kit, which includes all the drivers and libraries and different reference samples that you can use for your devices. And we have the NRF Connect for desktop application, which actually includes all the application that you run on your desktop together to complement the NRF devices. This could be a programmer application, a modem trace application, LTE link monitor application to send and receive 80 commands. And at the end we see the NRF Cloud, which is our cloud service, where we have different cloud services that supports cloud-to-cloud support through REST APIs and also device to cloud. We include different services such as location services. We have assisted GPS, predicted GPS, which basically downloads different satellites data from the LTE network before turning on the GNSS receiver to acquire a GPS fix. So this is much quicker and much lower power than using the GPS itself to download the satellite data. And we also have the multi-cell and single-cell location service as well, which uses the location of the base station and several base stations to have better accuracy to get the location through the LTE network instead of GPS, and this is almost not using power at all compared to GPS. So this can be very great to use for application where you need to have ultra low power. And we are also adding a lot of new services in the future on NRF Cloud. On the right hand side we see the NRF 9160 development kit. This is a standalone development kit for the 9160, and it's bundled with the eSIM from iBasis, and it also has a NRF 52840 board controller with Bluetooth low energy support on board. So we have 3 different antennas on this DK. We have LTE antenna supporting all the bands that the 9160 support, and also we have a GPS antenna and a 2.4 gigahertz antenna for the 52840. Which is something that's not shown in this slide is the Thingy91 prototyping platform. This is a standalone device as well with its own battery and a lot of sensors and a very small footprint. So this is a good device to do some proof of concepts and some easy prototypes, for example. And now just to have an overview of the SDK. First off, a small description of the left hand side here. It's the block diagram of the 9160 system in package. It includes a power management IC, different passives and crystals inside here. And on the middle here we see the microcontroller unit, which is the ARM Cortex M33. You have support for ARM Trust Zone. It's dedicated to flash and RAM and different peripheral support, SPI, I2C, UART, the usual suspects. So you have your application running on this side. You have your own dedicated area here. And on another separate area we have the modem, which has its own flash and RAM and support for GPS, LTM and NB-IoT. On the right hand side you see that you also have the RF front end. You just connect some antennas to the 9160 system in package and a power supply, for example a battery, and some sensors and a SIM card. It's yeah, that's the typically design you can have on the system in package. On the right hand side we see the separation between the application core and the modem core. So let's begin with the modem core. Nordic Semiconductor provides a modem firmware for our customers, which is a binary file which is certified for different carriers. You have all the inside the modem here. We have the physical layer, and the modem firmware supports the different layers, the IPv6 support, IPv4, TCP, UDP, GPS, TLS, DTLS, etc. inside here. On the application core you are running typically the NRF Connect software development kit, which includes the modem library, which enables different APIs you use to communicate between the modem and the application core. You can enable different protocols on your application core. You have support for HTTP, MQTT, lightweight M2M, CoAP. We also have the carrier library, which you need to enable for some specific carriers to be certified. We also have a link controller library, 80 commands library to do 80 commands to your device, for example. It depends on what your application is and what you need, so you enable what you need and disable what you don't need, so you can actually optimize your flash pretty good through this. On top of that, we also have support for different libraries and modules for connecting to NRF Cloud to enable different cloud services, Amazon Web Service and Azure, location and firmware over the air, etc. And on top of that, you just write your own application, either based on our samples and application or just through your imagination. Yes, first just some notes about the modem. We have earlier released the modem firmware 131. The full changelog link is added here. and also the compatibility matrix, which recommends you which SDK together with the modem firmware version you should use. So first off, we have the modem library, which is the now version 1.4.1. It enables more of the features included in the modem firmware 1.3.1. We have general bug fixes and improvements. We also added a separate version of the library capable of outputting logs. This is beneficial when you have to debug your device, for example. And we have also added some more GNSS flexibility parameters. And we have also removed the GNSS and PDN socket, which was replaced in the SDK version 1.5.0 by GNSS version 2 API and PDN library. Now they are completely removed because it's deprecated. Some new libraries. We have the location library, which enables you to use GNSS, assisted GPS, PGPS, and also cellular, single cell, multi-cell, as well as Wi-Fi positioning directly through this library. And also we have added a 80 shell library, which adds a 80 command shell command to your shell, so you can just write to your device through a terminal to send and receive different 80 commands. And we also have the LTE link controller library updates, including neighbor cell measurement search type, timing advanced measurement time to current cell data events, and a lot of other features and fixes in this library, as well as many other libraries. I'm not going to go through all this because it's a lot, so I just recommend you to go to the full list attached at the bottom link here. Some device management updates. We have the lightweight machine-to-machine carrier library version 0.21. You have now support for non-bootstrap custom URIs and also support for reading information from a smart card. We also added cellular connectivity objects and location objects and added new events to indicate the modem domain events. You have to enable this carrier library if you're going to certify to some specific carriers. This is listed on our website, which you can find on the link here. And also some updates to the lightweight machine-to-machine client utils library. This is actually based on Zephyr's lightweight machine-to-machine stack, and this can be used to have your own device management on your application side. We have added support for firmware update objects to use the FOTA download library, also added full modem firmware update support. Just some quickly some samples we have updated. First off, it's a new sample we have added in our SDK. It's the NRF Cloud REST photo sample, which is demonstrating how to perform photo updates using the NRF Cloud REST APIs. We also added some updates to the HTTPS client sample. We have added possibility to use Trusted Firmware M and Zephyr's own embed TLS stack instead of offloading the TLS stack in the modem. We have also support for lightweight machine-to-machine client sample, added support for Thingy91, so you can use the actual sensor objects using the sensors on board, and also some additional lightweight machine-to-machine objects, such as the full modem support. And also some new commands and support in the modem shell sample. And for the GNSS sample, we have added periodic fixes, power saving, low accuracy fixes, NRF Cloud, assisted GPS and PGPS support. So we have removed the AGPS sample from the SDK and instead added that support into this GNSS sample. Just some small updates to this fully fledged asset tracker application. We have added support for assisted GPS, PGPS, in the Azure IoT Hub integration. We also added content type and encoding properties to outgoing Azure messages, as well as split up the project configuration files to quickly build your application for different configurations. So when you build your application, you can just point to the different project configuration files you want to use, depending on which cloud you're going to connect to, if you're going to build your application for low power, and if you want to enable the memfault debug properties, etc. And quickly, just some updates on the Zero LTE Modem application. This application enables you to just use the 9160 as a modem, and you have your own external MCU sending 80 commands. You can also add your own 80 commands into this application depending on which functionality you need in your application. So just some new commands that we have added here is NRF Cloud command. You can send receive from the NRF Cloud through JSON messages in data mode. You also have the ability to read out the security tag and UUID. And also we have added a separate UUID command to read out directly from the modem. And some new 8 commands related to the general purpose inputs and outputs. Just some tools that we have for saving power. We have the online power profiler, which is a tool that you estimate the current consumption of your device depending on different scenarios and networks. This is a free tool on our website. And we also have the power profiling kit 2, which you use to actually measuring the current on your devices. And we have the power optimization guide, which will guide you and recommend you what you should do to optimize your application. Just some links at the end here. We have the modem firmware 131 changelog, and we have the compatibility matrix, which highlights which modem firmware you should use together with the SDK version. And at the end we have the full list of all the certification that the 9160 has.